Hello everyone, my name is Misty Noel and welcome to the first video in my series of kinesiology labs. Today we're going to be talking about Newton's 3 laws. Newton's first law, the law of inertia, states that an object at rest will remain at rest unless acted upon by an outside unbalanced force. Same as how an object in motion will remain in motion unless acted upon by an outside unbalanced force. And this can be easily shown using my whiteboard marker. As you can see here, my object is at rest and it will in fact remain at rest because although there are forces acting upon it, like the force of the marker pushing down the table, it is in fact equal and opposite to the force of the table pushing back up against the marker. Thus, it will not move until I push it, adding in my unbalanced outside force. Here it wasn't the greatest example of it rolling. We can try that again. And even then you'll see that it stops. But that's because of things like the friction against the marker and the table and the air resistance from, the air. If this were to happen outside in the vacuum of space, this marker will continue moving unless it hits an alien or an astronaut. Newton's second law states that the force is equal to the mass times the acceleration. This means that acceleration is produced when a force acts upon an object, and the greater the mass of that object, the more force you're going to need to create said acceleration. To demonstrate this one, we're going to use this apple and my car. First, we'll use the apple. Because the apple has a fairly small amount of mass, I have to apply a fairly small force to get it to accelerate. But what about the car? As you can see here, I had to apply a significant amount of force to move this because it's got a significant increase in mass. I'm not gonna lie, the parking brake was on while I was doing this, but you get the gist. It's bigger and it's harder to move. Newton's third law states that for every action there is an equal and opposite reaction. This can get a little weird at some times because you're thinking, man, I'm pushing down at this table. Is this table really pushing back on me? The answer is yes, because if you think about it, you and I are just made up of atoms. Hey, there's atoms on my shirt, but we are made up of atoms. And the outside parts of our little atoms are a bunch of different electrons. Remember those electron probability clouds? Yep, those are here. Well, my hand's coated in electrons, and this table's coated in electrons, and does like or does like repel like? Oh yeah, it repels like. So as my electrons come closer and closer and closer to these electrons, they're actually pushing against each other. And when I push down on the table, the electrons will push back against me because they don't want to be together like stinky men in the elevator, right? So that A means that you've never actually touched anything in your life, including the fact that you've, hugged your children or your mother or anything. Contact never really occurred. And B, whenever you push something, it'll push it right back.
So how does this apply to sports? It means that when I'm skiing, I will continue to ski until I hit another person or a tree. When I'm jumping, it's because the force that I'm applying to the trampoline is being applied right back at me and throwing me into the air. And although I don't have a video of me lifting weights, this is a good representation of why I don't lift weights, because the heavier they are, the harder it is.